Very good. So right now, I think we are running late about 10 minutes, okay? I'm going to pass for the next speaker, which is Paulo. You know, Paulo is a backend developer here at Mindera. He's been with us since end of 2017. So he has started as a Java developer, but right now he's really focused on Node.js. He has involved, in several projects in Mindera. He's addicted to video games. So maybe, I don't know if he's going to show up or he's just playing at the moment. Let's see. He also likes to craft his beer. And also he used to play football. But I don't know, maybe with the age, he's just focused on video games and playing FIFA. Let's see if he can join on the stage or if he's just playing FIFA. Let's see. Paulo, come on.
Hello, can you hear me?
Yes, you even have the headphones of a gamer. It's like
yeah.
You cannot lie. It's amazing.
It's for the sound quality, Pedro. Thank you for
Well, enjoy, have fun. Okay.
Thank you.
Bye, Paulo.
All right, so let me start presenting my screen, and hopefully, all right. And then I can play it. 1 second, I can see if you are. Oops, sorry. All right, so let me try and present my screen. I'm losing the possibility to see if you are seeing the screens or not. So let's start up. All right. So first of all, good afternoon. I'm doing a presentation about serverless, and what I'm going to present today is 10 things I learned using serverless. All right. So first of all, I work as a backend developer, and in my current project, that is on Elm, I'm using a serverless architecture. So starting up to present what is serverless. So serverless is a way of running application code without the need of provisioning and managing the underlying servers. The user only writes functions that are afterwards executed by the cloud providers, and functions automatically scale based on the traffic. So the user only pays for the time consumed, the memory, and the invocation count. And usually on a serverless application, you have two kinds of serverless ways of or applications. You have the function as a service that are really the platform that runs your code, and you also have backend as a service in the serverless world that are authentication service, for example, search. Yeah, cool. So this talk is going to be a little bit about my personal my personal work or my knowledge. So I'm going to talk a little bit more about AWS Lambda. That is the one that I use on my current project, and also I will talk a little bit of the tricks are using Node.js or developing Node.js application. So feel free to visit any kind of service that provide a serverless way of running your functions, and also any language. So what is AWS Lambda? Lambda is a service that allows you to run code without that need of provision and managing servers. And how does it do it? The developer only writes the function code, and the cloud provider, AWS, is responsible for running it. And this happens with every cloud provider. So the integration with your function code is that AWS provides an interface for your function code, and then if you implement that interface, you are able to receive a response, a request, and return a response. So let's move on. So these are the 10 things that I'm going to present on this talk. So yeah, first of all is that service application run on containers. Second, that they can be triggered by different events. Yeah, cold starts might impact several users, and so on. And I'll explain each of one each of them more specific. So moving to the first one, serverless application actually run on containers. So what does it mean? So developing a serverless application doesn't mean that they don't have servers. That will be impossible. But the provision on the servers is managed by the cloud provider usually. So each invocation of your function requires a server to handle the request, and under the hood, application actually run on containers. So how does it help in entering the serverless world? So it gives you a perspective of they similar to like launching a Node.js application with a container. The startup are really similar to having that, but they run on demand, and the servers are not always running. So we also have some kind of isolation for another executions, and this is kind of helpful to know the developer responsibilities. Second point is that functions can be triggered by different events. Typically, you write your function code for handling HTTP requests, but the cool thing is that they can also be triggered by a queue, for example, a topic, a stream, or a cron job that triggers an event, and then you can respond to that. Here are some examples of services on the cloud that can trigger your function that you can use. And now, how does it differ from having your own infrastructure? Is that functions only execute after receiving an event, and the cloud providers manage the logic to trigger that function. So you don't have the logic to kind of do polling to the queues. The cloud provider manage that for you. And you should also be considering that events have a different scaling of your functions. For example, if you receive many messages on a queue, you have many instances created of your functions. And the awesome part of that is the user only pays when the function are requested. So it's a perfect scenario for example, event-driven application. Okay, cool. Next up, cold start might impact several users. This is like demystifying what is a cold start. And what is a cold start? So first of all, in a normal serverless application, you don't have actually a server ready to answer your request. So how does it work? First, it checks if there's already a server, a function ready to answer your request. And if it's yes, it automatically responds to a request. And that is called a warm start. If not, a new container needs to be launched to answer your request. So how does this work? So the cloud provider has to pull the download the code for, usually in case of AWS Lambda is a S3 bucket. It has to download your code, and it's like launching your application, and then is ready to receive a response. So in the right side, in the left side, you have the flow when a cold start happens. On the right side, you have the request life cycle. Cool, interesting thing. So what is the responsibility on a cold start that the user can optimize? It can optimize the amount of code it loads into memory, and the application code. If it's faster, it will be your code will be faster, and also the download size also impact the download time that it takes to download your code and then bootstrap your application. So especially on AWS Lambda, one function can only handle one request at a time. So what does it mean in terms of cold starts? When you have, for example, 100 users calling your functions, if you don't have 100 functions ready to respond, it will be 100 cold starts in your application. That is bootstrapping all the 100 servers to answer your requests. And also, cold starts can have a great impact on application performance, because differently from having a long-lived server always running, that you only have a few cold starts when you need to start up a new application. In a Lambda world, in a serverless world, you'll have more of them always happening. But after they are restarted, they are reused. I think it's at least 15 minutes of without inactivity, and then you can also reuse the already started application. Cool. Now it's another topic, that is load stuff you need on the startup. So AWS Lambda is like a cool trick to optimize the cost, but AWS Lambda does not charge the user by the cold start time. This is a trick to optimize and reduce function. And an example is when you want to load like a database client, if you associate the client with a static variable, this will run on the startup of the function. So you can save some costs by doing that. So yeah, there is a resource that I show at the end that is really cool to demonstrate this kind of usage. So also a cool thing that Lambda use a lot of resources and memory initializing the functions to reduce the cold start time. So you can use that. And yeah, like I said, you can save static variables and also use the dash tm temporary folder in the following invocation, because the Lambda saves that for further invocations. Cool. So next up is you should use a model bundler. This is mostly specific for my work, that is with Node.js and TypeScript. And what can it help? Using a module bundler will create a bundler with only the required code, so it will affect your cold start. It will reduce the download size and also improve the cold start of the function. And how does this help also reducing the cost? Is because it reduces the memory required to run your function. Yeah, and that's it. And that if you have like faster code than with using less memory, you have improvement on your application cost. Cool. Next up is the topic that's load the minimum dependency into memory. So you could reduce the amount of dependence load into memory, and that affects also the cold start. Import only the required modules on the application code. This is mostly there is an example is using the AWS SDK that has a lot of clients, and if you only import the right one, you will improve your application cold start, and it'll be quicker to respond to the users. Also, it reduces the memory that you require to load your dependency into memory, and it eventually reduce your costs. This is some graphic that I take from an article that really shows up the difference between using a module bundler or not using, and importing a client only and using a full SDK. For example, in the case of specifically AWS SDK. Cool. So next up, it is more like a developer tip. That is, you should use middlewares and focus more on the business logic. So when you are developing, you can use middleware stack to share some code with another functions that have the same same like correlation ID, logging, error handling. Everything will to be the same, even parsing the request body, and you can avoid duplicating that logic in all your functions. And you will focus more on the business logic of your function. Some examples are MIDI JavaScript, that is a middleware tool, Lambda Power Tools also, or you can build your own custom middlewares and like integrate it with your function code. Another cool topic is to use a tool to manage deploys. That really helps a lot instead of creating the resource manually on the cloud providers. And some examples for that. All right. So first of all, that explain a little bit. So the tools are using infrastructure as code. So improve the deployment is faster, and usually you have the code on your source repository to deploy your application. You can also the tools also allow you to run the application code locally. Some examples are the serverless framework, the serverless application model that is proprietary by AWS, and also the cloud development kit, the CDK. All right, another important topic is that you should be careful when managing database connections. And basically, why does it happen? Because functions scale a lot more than your servers. Your servers usually have a limited number of them, like 3, 4, and functions really scale up even to 100 if they have 100 requests per second. So if you have some hosted database with servers, you should consider you should be careful when manage them. You could also use database servers managed by the cloud providers, where you don't have that kind of trouble, such as and a database like Dynamo, that those connections are managed by the cloud provider. There are some serverless packages that also consider the database connection numbers that you could use to help you on the development. And AWS also provides a cloud proxy that also manages the database connections. So you can use that between your hosted database and your application. Usually they proxy for a MySQL database. I think it's RDS. So you can use that proxy as a way to manage your database connections. Right. So last topic that I want to chat about is that you should use monitoring tools. So in a production environment, usually there's a lot of component involved in the business flows. There are a lot of functions running. So adding a monitoring tool is really helpful for increasing the debug capabilities. And the tools also provide, in case of a serverless world, also provide monitoring, tracing, and alerting. Some examples is Amazon X-Ray, Hexagon, Datadog, and Lumigo. Yeah, and I think I ended the presentation. But first of all, let me say that there are some resources, and I did a demo project, so you can check a way to bootstrap your serverless applications. There are also some talk resources that you can check that tells you a little bit more about each one of the topics. There are cool articles to deep dive in your applications. And yeah, as a disclaimer, please always consider checking the requirements of your project before going for a serverless implementation. And yeah, I think that sums all the 10 things I learned using serverless. Yeah, thank you. Hopefully that was a cool presentation.
That was very good, Paulo.
Yeah, sorry, let me... All right, thank you, Pedro. Yeah, hopefully please join me on the question and answers after if you have any question. And
yeah, sounds good.
Back to you, Pedro.
Thank you, Paulo.